Hello everyone, I am Masood Ibn Abdul Wahid. Today we are going to see the solution of some electrical circuit problems which is taken from Anna University question paper April-May 2023. So the topic of today's discussion will be Kirchoff's law. Actually this video is the continuation of the previous one. Already we have discussed more about Kirchoff's laws and the comparisons between Kirchoff's law, mesh analysis, nodal analysis. And we went into the solution of one problem using KCL and KVL. So we are going to take another problem which is again from an university question paper. So once again we will look into the keynotes for the solution of a problem using Kirchhoff's law or mesh analysis. See, in both the cases we are going to have some loop directions and we are going to assume current directions. In the case of Kirchhoff's law, we will be assuming branch currents, and in the case of mesh analysis, we will be assuming loop currents. According to the loop direction, we will be assuming the voltages as voltage rise or voltage drop. When the travel direction is same along the assumed current direction, so then we will be having a voltage drop. And if the travel direction and the assumed current direction are opposite to each other, so this is called to be potential rise or voltage rise. These two are in the case of resistance, and the same for batteries also we have discussed. So if the battery is in this case and the current assumed is in this direction, which is internally minus to plus, it is called to be voltage rise. Whereas according to the current direction assumed, the current internally into the battery, if it is from positive to negative, we have assumed it to be potential drop. So with this four case of potential rise and drop, today we are going to solve another problem. The problem states that find the ratio of current in the load resistance to that taken from power supply. So the given circuit is this one, which is having 5 resistances connected with a battery. So already they have assumed the branch currents and they have given with the value of current in each resistors. The question is the ratio of current in the load resistor, that is they have mentioned the 60 ohm to be the load resistor, to that of the current delivered by the battery. So they have asked the current ratio, that is I1 divided by I. Before the solution, let us see the same circuit in a different perspective so that you will have a better understanding about the circuit. Because here we have crisscross wires, but here there is no crisscross wires, which we can see it to be a simple one. So let us take the first loop in the given circuit to be ADBA, which is this one. So the travel direction is from A to D, D to B, and B to A. So when you travel from A to D, there is a current in the same way. So as you know that the loop direction and the assumed current direction are in the same direction. So started with a minus with a potential of 40 multiply I minus I2. And from D to B, again the travel direction and the current direction are same. So started with a minus with a potential of R multiply I in that particular branch, which is this one. And we will travel from B to A, where we will face with the battery, and according to the assumed current direction, the current is flowing internally into the battery from minus to plus. So it is a potential rise. So started with a positive V, which is equal to 0. So rewriting this equation, so you will end up with this equation, which we can notate it to be equation number 1. And let us go into the second loop in the given circuit, which is ACDA, and the loop is shown to you here. So let us start traveling from A to C, where we are having a resistance and the current direction assumed is in the same direction of the travel direction. So started with a minus with the particular voltage drop, and from C to D again we are having the travel direction and the current direction to be same. So we will have a voltage drop of 60 minus 60 I1, and we will travel from D to A, where we are having opposite directions between the travel and the assumed current. So this is assumed to be potential rise with a voltage of 40 multiply I minus I2. There is no battery in the considered loop, so the resultant voltage of this loop will be 0. So again manipulating the written equation and separating out the I terms, I1 terms, I2 terms individually, we will end up with this equation, which we can notate it to be equation number 2, which is corresponds to loop number 2. So let us come into the last loop, loop number 3, which is CDBC. So this is the loop we considered. So we will travel from C to D, where we are having the travel direction and the current direction to be again same. So started with the minus with the particular branch voltage, which is this one, and D to B again travel direction and the current assumed current direction are same. So again it is a potential drop with this much voltage. And when you travel from B to C, the travel direction and the current direction are of opposite. So this is assumed to be a potential rise, which is of plus 40 multiply I minus I2. Again, this loop number 3 is not having any batteries, so the resultant value of voltage will be 0. So manipulating it, you will end up with this equation, which we can number it to be equation number 3. So now we have 3 loops, we have 3 equations. By solving those 3 equations, we will get the required currents I, I1, I2. Let us take the first 2 equations out of the 3 what we have formed. So this will be equation number 1 and this will be equation number 2. Let us try to cancel out the I2 term. So for that, add these 2 equations, number 1 and 2. So when you add, the positive 130 and negative 130 will cancel out, end up with this minus 90I minus 150I1 is equal to minus V. So this, let us consider it to be equation number 4. Let us take the equation number 2 and 3. We will add these 2 equations so that the I2 term will cancel out because of positive and negative sign. The resultant equation will be minus 50I minus 250I1 is equal to 0. So we will note it to be equation number 5. Now solving these 2 equations, we will get the I and I1 value, which is the required current to find out the ratio. So to solve these 2 equations manually, so let us multiply the equation number 4 by 250, which is the coefficient of I1 in equation 5. So by doing so, we will end up with this equation, and multiply the equation number 5 with 150, which is the coefficient of again I1 but in equation number 4. We got 2 equations by the multiplication. Let us subtract it from one another. For that, let me multiply a negative sign throughout the second equation. These 2 will be cancelled. The resultant will be negative 15,000I is equal to negative 250, from which the I can be calculated to be 0.01667 V. Just one point to be noted, this V is the battery voltage V. We found the battery current in terms of battery volt. Let us substitute this I value in equation number 4. So manipulating this, you will end up with the current I1 to be negative 3.33 milliamps, so which I have written it to be 10 power minus 3, which is again the current I1 is found in terms of battery voltage V. Let us go into the question what it is mentioned in the given problem. The required ratio is I1 by I, minus of 3.33 multiply 10 power minus 3 V divided by 0.01667 V. So the V and V will get cancel out each other. Current ratio between the load resistance and the battery, nothing but I1 by I is equal to minus of 0.19976. So according to the given question and the given current directions, the value of I1 by I is found to be negative, since actually the current I1 is flowing in the opposite direction to that what it is mentioned in the given problem. So as usual, let us plot the same circuit in Proteus and check what is the value of currents we are ending up in each branch. We have plotted the same circuit in the Proteus software. Only one additional thing what I did is I have included the ammeters in the appropriate place to measure the currents, namely I, I2, I1. How to plot the circuit? If you are new to the Proteus, you can watch my previous videos where I have explained the step-by-step procedure to open the Proteus and how to save a file, how to open a file, how to create a new file, how to pick the devices, how to draw it. Everything I clearly explained in the previous videos. For those new viewers, you can please refer to the previous videos. I will attach the link of that video. Okay, now we will run the simulation. So you can notice that the current values are read to be 0. This is not indicating that there is no current. What the actual thing happens here is the value of current which is measured by these 3 ammeters are very small. So what we can do is we can change the range of these meters so as to read out the low currents clearly. For that, what we have to do is, first of all, stop the simulation. You can change the range of this meter by double clicking on the meter. Double click, and here you can see the display range. Change it to be milliamps. Okay. Also for this, milliamps. Okay. And now you can read out the values. So one thing, that the given circuit is having a battery of V volt, where we found in the manual calculation that it will cancel out, so that to check it in the Proteus, I have given the value of the battery voltage to be 1 volt. So again, run the simulation. So you can see here the current what it is measured here is 0.01, which you can even still see the next digits. It will be 0.01667, which is 0.01, what you are seeing in the display. And this is the current which is measured to be negative of 3.33. Already in the manual calculation also we have seen the current which is through this 60 ohm resistance is minus 3.33 milliamps, that is multiply 10 power minus 3. So this is the current which is we have manually calculated also, and we are experiencing the same current in this branch in the Proteus also. So what we have manually calculated is correlating with the Proteus results. In today's video, we have discussed the solution of Anna University question paper problem on the topic Kirchoff's laws. The question is taken from recent question paper April-May 2023, and we have manually calculated the answer of the given question, simulated it in the Proteus, and correlated the results between the manual calculation and the Proteus simulation. I hope this video was useful to you. Thanks for watching the video. Let us meet in another Anna University question paper problem. Until then, I am Masood Ibn Abdul Wahid signing off.